Welcome back. In this lecture, we'll discuss numbers. Numbers are very simple if you understand basic math, so it shouldn't be a problem. But don't worry, I have got you. Numbers. There are three types of numbers in Python. One of them is an integer number. For example, just no point, just simple integer number. There's another type of number called a float number. It's a data type. Again, int is a data type and float is a data type. We will discuss that in type conversion in the next coming videos or lectures. And float number is, for example, 33.33444444. Pretty cool. That's a float number. Now there's another kind of number that's called a complex number. Now don't worry if you don't get this one, but you probably studied this. There's a complex part and there's a real part. You don't have to worry about this. We don't use this a lot. Sometimes we do, but not a lot. Very rare that you will use this in your journey. And so you don't have to worry about this operator. We will not discuss the complex number operator. Integer and floats are what we will use in this course. Now, let's get ready to do some math, shall we? I'm going to take two numbers, x equals 87 and y equals, 42, let's say. I have two numbers now. Now let's perform some operations. You might have been thinking, well, I have not done x plus y, x minus y. Well, we'll do that now. Let's say I want to do addition x plus y. X plus y is the way you would do addition, a plus operator. Remember that in the string section we did plus to concatenate. When you use that thing between numbers, it will do addition. Now let me show you if that did work or not. Addition, my bad. Same way, running the code, numbers.py, and it gives me 129, which is the result of this addition. Now let's talk about subtraction. Subtraction is pretty simple. Well, you probably know, but I'm just showing you that this is how you do it in Python. Just use a minus sign and it'll do subtraction. If I print this, it should give me the answer. 45. Pretty cool. Not done yet. We're also going to talk about multiplication, which you probably already know. I mean, you know multiplication. X multiplied by y is going to give me 42 multiplied by 87. Well, it might be a little hard for you to do it yourself. Well, 2 7s are 14, 2 8s. Okay, I'm not going to do that. I'm just going to ask Python to do it. So just type in print multiplication. And you do python numbers.py and you get a big number. Might have taken you some time doing it, but now you can do it easily here. Again, not a big problem, but now there is a problem. Now we're talking about division. Now there are two kinds of divisions. Now first is a pure division, which you can call it whatever you want to call it. I like to call it pure division. Pure division, I'll explain it to you in a moment what it is. You just divided x divided by y. Pretty cool stuff. But what's the problem here? Let me show you what the problem is. Pure division. It's going to give me an answer like this. And sure, you probably will use this a lot. Just simple float division. It's called a float division or pure division. Float division is a better word. Now, I don't want to use this. I just want to use this two part. And this is also used a lot to divide integers, right? And you can also call this one, the one that I'm showing you now, an integer division. But it's more famously called floor division, my bad. And floor division is pretty simple. Let me show you how. If I do x divided by y, what will be the answer? Remember that whatever the value is on the point side, this will get dismissed and you will only get 2. That's it. What floor does, it just reduces the, it throws that thing to the floor. That's a very good analogy of floor functions and ceiling functions, which you're not studying them now, but floor function just collapses the decimal to the smaller value. So even if it is 2.99999, floor will convert that to 2. Now let's print this floor division and you should get, well, a 2, as I said. Pretty cool stuff. Now you will use both of these divisions, and even if you forget any of those, just Google it. It's not a big deal. I'm going to comment that out for now. And now I'm going to talk about the modulus operator, another very important operator. Mod is just the remainder of with the result of the floor division. For example, let's go through an example of the same thing, right? 42 divided by 87. 87 divided by 42. So 42 2s are 84, right? 2 multiplied by 42 is equal to 84. But what is the remainder, right? Remainder is 3, right? When you divide it by 84, 87 minus 84, that's the remainder is 3. 3 is the remaining value, which this simple division tries to divide when it does this. 2.70714 tries to divide that small value. But with the modulus operator, it just directly gives you the answer that, well, the remainder is 3. We're divided by floor division. We couldn't do it properly, but this is the answer that's remaining. Now, I calculated that using the mod function, and if I print this mod, they should give me their answer, which is 3. Now, what if the one value is bigger than the other? Not a big deal. The same value will be returned, because, for example, if you divide 42 by 87 instead, 42 by 87. Well, you can. 87 zeros are 42, and then you have to use a point, and then it'll divide even further. So what if I print 42 divided by 87? Just see what happens. It's 0. And 42 minus 0 is, you guessed it, is 42. And if I print as modulus, it's 42. Pretty cool stuff. Now, we're not done here. You're also gonna have to learn the exponential operator, which is also used a lot. And if you ever forget any of these functions, never remember or memorize these. Just Google it. That, oh, what is the operation for multiplication? What is the operation for exponential? Never memorize ever. Though the syntax, you don't have to memorize, you just get used to it. Now let's talk about the exponential operator, and exponential is also very simple. No need to worry, it just takes a raised to the power. For example, you studied probably in simple basic school, you used to take raised to the power. For example, 2 raised to power 2 means that 2 is multiplied by 2 times. 2 multiplied by 2. If it is 2 raised to power 3, it's 2 multiplied by 2 multiplied by 2. I know I'm overgeneralizing things, but if someone doesn't know it, it's not a problem. This is how the exponential function works. The raised to the power means that it multiplies that how many times. So let's calculate the exponential of something. Okay, let's calculate the exponential of x raised to power y. X is now multiplied 42 times. Let's print it. Can it do it? Yes, it can. It's a big, gigantic value. Now that's big. And this is how you calculate the exponential. Now I want you to do some exercises, because as a beginner, I also know that it was very a little mind-boggling for me at first. Not that I also knew these things before, but it's a little hard to just have it in your mind all the time. So I have an exercise for you to solve. Just solve these. I will have that in the script file attached with this recording, so if you can't find it, not a problem. Solve these. 5 modulus 10, 5 floor divided by 2. I mean, it could be very easy for you too, but if you have a problem with this, it's just for practice. 70 floor divided by 30. What is that? What is 53 modulus of 7? What is 34 divided by 23? That's simple divided, so it's gonna go into points. What's 4 raised to power 2? That's 16, of course. But I mean, you might say this is very easy, but it's just to make sure to validate that you actually know that stuff. I'm gonna see you in the next video, and things are starting to get more exciting. So I'll see you in the next one.